Okay, so I want to do some common logs with you. Like I said, most of the time it's going to be base 10. And this is what your calculator can see unless you have like a TI 97 or I don't even know if they make that, but something crazy. Okay, log base 10, so 10 to the what equals 100. Okay, so obviously 10 squared equals 100. So there, y equals 2. Okay. Also, log base 10, 0.01. In other words, 10 to the what equals 0.01. So this is obviously going to be a negative, and that's negative 2. Okay. 10 to the negative 2 equals 0.01. Let's look at that one. 1 to the 10 squared, or 1 over 100, same thing as 0.01. Right, so y there is negative 2. Okay. What else? Log base 10 equals 5. So 10 to the what equals 5. Okay, not quite as easy as the others. This is one that you would have to put into a calculator. And how you do it is you do 5 log enter. Okay. 5 log, and then that's going to give you 0.69897. I don't think I give you one like that because I don't let you use a scientific calculator. All right, so don't worry about those. And there's another one like that, so don't worry about that. Okay. All right, so now let's get into graphing logs. Oh, I want to go back to the homework. I looked at the first part of the last video. I saw that I had put the picture horizontal, so there it is. Okay, set 5, and those are the problems for 9-3. Okay. Sorry if I make you dizzy with these videos. All right, so if we're graphing 2 to the x, okay, think about it. 2 to the 0 is going to equal 1. Okay, so 2 to the 0 equals 1. All right, 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. But again, we're never going to get to negative territory. So it looks something like that. Okay, and you can do the chart where you would plug in negative 2, negative 1, these are your x's, 0, 1, 2, 3. And then your y's you would get. Okay, so 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared, 4. Oh, you can't see what I'm pointing to. 2 cubed, 8. Okay, so that's how it graphs like that. Now, if I'm graphing the opposite of that, okay, or log base 2 of x, okay, equals y, then it's the inverse, okay? So you could just reflect this over y equals x. And this is when I become bad at drawing, but it would look something like that. All right? We didn't get into that much with the last lecture, and I think you might have had to do some in the homework with the inverse. We did the inverses, but not necessarily graphing the inverses. So with an inverse, here's my function, and here's the inverse of it. You just reflect it over the line y equals x. And think about it, when we actually evaluated the inverses, we swapped the y and the x and then solved for y. So that's where that comes from. Okay, what else? We have to look at some shifting of graphs too, I believe. Yes. All right. So if you just want to see how involved I want to get. I'm looking at your homework. Okay. So if you have the general function of log base 10x, okay, that graph is going to look like this. If I then look at the function, of log, base 10 of x minus 1, then that's going to shift it 1 to the right. Even though it's minus, this is counterintuitive, okay, but it shifts it 1 to the right. So it would be over here. Okay. But then if I were to add 1 outside of the parentheses or subtract 1, that's going to shift it up or down. So let's look at another one. Again, I'm going to have log base 10 of x. Okay, so the same as last time. And then I want to add 2 to it, let's say. 2 plus log base 10 of x. Okay. That's going to shift it up 2. So I'm going to go 2 up. There. So this is log base 10 of x. And then I go up 2 plus log base 10 of x. Okay, if it was minus 2, then obviously I would go down. And if this was plus 1, I would go left. Okay, counterintuitive. Minus 1, you go right. Plus 1, you go left. Let's label these. This was log base 10 of x. And this one was log base 10 of x minus 1. Also, just like if we were in class, if you have questions, email me, post them in the comments of Google Classroom. All right, so that should be good with the logs. One more, sorry. All right, I don't want to do this. Okay, you have log base 10 of x. And this time we're going to have the negative log of 10x. So log base 10 of x has not changed in the last 3. And that's still going to look like this. And the negative log of 10x is going to swoop down this way. Delete there. All right. All right, then we get into the natural logarithmic function, ln and e 2.72, again approximately. So I'm going to save that and change a base for the next snippet.